Mrs. Shomana Gracia Jacob, ME in Computer Science, lecturer in CIPAT, Chennai for the past 3 years. She has published 4 national and international papers. She has won Star Achiever Award for academic proficiency.
Welcome to the UGC lecture series in Computer Science. We have been seeing the fundamentals of programming in the software language C. Today we will look in detail at the operators and expressions that are available in the C language. So before I begin, let me tell you what is an operator and what is an operand. An operator represents an operation to be performed on some data and it should give some value, some result. And an operand is a data item on which the operator performs the operation. So every operator needs some data, some value on which it has to operate, and that particular data on which it operates is called an operand. There are plenty of operators available in the software language C. Just to give you an overview of all the operators that are available in C, here you can see the type of operators and their symbolic representation. We have arithmetic, relational, logical operators which require a minimum of 2 operands to perform their operation. We have the increment and decrement operators which come under the unary type which require just a single operand. And we have the assignment operator, bitwise operators, comma operator and conditional operator. So if you will see, we have a total of 8 different classifications of operators in C and their symbolic representations. Now first we will look at the arithmetic operators in C. In this we have 2 types, we have a binary operator and a unary operator. Now we will look at each of these in detail. A binary operator is one which performs numerical calculations between 2 constant values. So the word binary indicates a minimum of 2 operands are required, and these operands need to have constant values during the time of their operation. So what are the binary operators that are available in this software language? Now this is an overview. We have addition indicated by the plus sign, subtraction, multiplication, division and modular division. An example has been given for each of these operations. Modular division is something in which you do not get the quotient as a result, but the remainder of the division as a result. Now that is the difference between division and modular division. Division is one in which you get the quotient of the division as a result. When you want to see the remainder, you go in for this modular division. So binary operators are ones which require a minimum of 2 operands for their operation. Next we have what is called the unary operators. Unary operators require only 1 operand for their operation. They cannot be used for an operation on 2 values at a time. So in unary operators there are many classifications. You have increment operators, decrement operators, the simple minus sign, address operator and size of. So the address operator is represented by the ampersand symbol. It holds the address of the variable in memory. So if you want to see at which memory location a particular value is stored, you give the ampersand symbol and the variable name. It will print you the result of that memory location. The size of operator is to tell us what is the size the data type holds. For example, we saw while looking at integers and data types about the memory allocation for a data type. Some it is 2 bytes, some it is 4 bytes. So the actual size that is held by a variable can be obtained when we use this size of operator. An example has been given here, size of x. So the memory allocated to that x variable can be seen by the user. So this is an example for the minus unary operator. When we want to assign some sign to a data value, we use this minus operator. Here is an example. Integer x, which represents that x is a variable. It is of integer type and it is a signed integer because we are assigning a minus value to that 50. And we can convert that minus 50 to plus 50 by again using the minus operator when we are assigning it to another integer variable y and we give minus x. So minus of minus 50 makes it plus 50 and it assigns the value plus 50 to y and minus 50 to x. Now this is how we use the unary operator minus, just to give a sign to a data value. Next we have the increment and decrement operators. An increment operator is one which adds the value by 1. For example, if the value of y is 50 and you give y plus plus or plus plus y, it adds 1 to 50. So, the value of y becomes 51. Now, in this increment and decrement operators itself, we have something called pre-increment and post-increment. Now, this is just an example that I have given here. We have two integer variables x and y, x holds the value 20 and y holds the value 10. And next, in the third step, we are doing the operation z is equal to x into y plus plus. Now, the value of x is 20 and the value of y is 10, and you have an increment operator there which comes after the variable y. So, because it comes after the variable y, it is called a post increment operator. So, the actual value of this entire operation will be only 20 into 10. That plus 1 will be applicable only after the multiplication operation is performed. So, that is not taken into account when the actual operation of multiplication is done. That is why the answer remains at 200. Now, if you look at the next set of statements, you have the same x is equal to 20 and y is equal to 10, but here if you see, you have x multiplied by plus plus y. Now, because that plus plus increment operator comes before the variable y, it is called a pre-increment operator. So, here while the operation is performed, before multiplication is itself, that increment operation is done. So, the actual operation that is performed is 20 into 10 plus 1. So, the actual value becomes 220. So, we are using the increment operator in both the functions, but the result for the first one is 200, but for the next one it is 220, all because of the positioning of these increment operators. So, I have just shown you an example for plus plus. The same thing holds good for minus minus also, which is called a decrement operator. So, decrement is it will reduce the value of the variable by 1. Increment will increase the value of the variable by 1. So, the position of that operator makes so much of difference in the final result. So, that is the importance of these unary operators. Next, we move over to relational operators. Relation itself, it means relation between two or more operands. So, you need to have a minimum of 2 operands in this case. So, they distinguish between two values depending upon their relation, and it provides the relationship between any two kinds of expressions. If the relation is true, there is a return value say 1, and if the relation is false, there is a return value 0. So, what does this indicate? How is it applied? Now, these are the relational operators available in C. You have greater than or equal to, greater than or equal to, and not equal to. It is very important here to remember the operator symbols, because we will be using only the operator symbols in the program. So, equal to and not equal to, if you will see, equal to has two equal to symbols and not equal to is having one exclamatory mark followed by an equal to. So, all these have to be kept in mind. So, if you will see the examples, 5 is greater than 4 because the operation returns true, it has a return value of 1. If you see the second example, it is given 10 is less than 9, which is not true, it is false. So, because the relation here proves false, it returns the value 0. So, based on the return value, the program will give us the result of whether one number is greater than the other or whether it is lesser than the other. So, this is how relationship between two numbers or between two expressions is evaluated, and the result is given to the programmer. Next, we move over to logical operators. Logical operators is to join two expressions, that is, so far we have been seeing about whether one operand is less than the other or not. Now, the same kind of operation, if we want to have two sets of cases and we want to get the result of whether both the sets of cases have returned true or not, or at least one case is true or not, in that case we go in for this logical operation. So, after checking of the operation, it provides a logical true, that is 1, or logical false, that is 0. This is applicable to constants, variables as well as to expressions. So, if you see here, you have the operators logical and, or, and logical not. The operators here are to be kept in mind, which is a double ampersand, a double vertical bar, it is also called the pipe symbol, and you have the logical not, which is equal to the not equal to. So, here if you see, two relational operations are combined. 5 is greater than 3 is a relational operation, 5 is less than 10 is a relational operation. If both the cases are true, then it will return the value 1 because it is joined by a AND operation, and we always know it is to combine two. Only when both the cases are true it should return a 1. The same thing if you see the next step, 8 is greater than 5 and 8 is less than 2. The second set of cases is false. However, it returns a true value because it is joined by a OR symbol. If any one of the cases is true itself, it returns a value true. So, this is how we evaluate the logical expressions. Next, we move over to the bitwise operators. Bitwise operators, very important to keep in mind that they operate only on integer operands. So, integers is the data types, integer, character, short, long, int, etc. Now, I said integer operators and I am saying character here. Characters also can be represented using their ASCII values. So, that is why that also has been mentioned here as an integer operand. So, the operators that are there in bitwise is left shift, right shift, bitwise XOR, ones complement, bitwise AND and bitwise OR. This XOR, AND and OR are similar to the binary arithmetic, where we have two zeros, it gives a 0. A 0 and a 1, in case of OR it returns a 1. In case of AND, both the operands have to be 1 if the final result is 1. So, I will just give you an example of how this bitwise shifting is done. The rest of the operations follow the similar order. So, here we have a number 8 and we all know its binary representation is 1000. So, when bitwise execution is done, this is how it is implemented in the computer's arithmetic. First, we have 2 raised to all the powers up to 16 because it is 16-bit integer, and we have from 0 to 15 represented as double digit values. And here we have written the binary representation of the number 8,000. So, it comes as 2 to the power 3 is 8. So, that is why we put a 1 in the third position. Now, the operation that is to be done is right shifting by 2 bits, that is shown as x greater than, which is a symbol for a right shift, is equal to 2, which indicates that the number x has to be right shifted by 2. So, x is 8 and that has to be right shifted by 2. So, if you will see the next step, the bit 1 moves from the third position to the first position because it is a right shift. So, it shifts right by 2 bits. So, if you will measure up its value, it is 2 to the power 1, which is equal to 2. So, 8 when it is right shifted by 2 bits, the final result to the programmer is 2. Now, this is the formula for performing a shift operation. Y is equal to n divided by 2 to the power s, where n is the number and s is the number of bits it has to be shifted. So, if you apply the same formula to this particular example, here n is 8 and s is 2. So, 8 divided by 2 square, which is equal to 8 divided by 4, the final result is the same 2. So, these either you can evaluate and see whether your answer is correct using the formula or using this shift operation itself. Now, these are the list of operators that have been available in C. We saw the arithmetic, the relational, the logical and the bitwise operators. In arithmetic, we have seen the binary and unary operators. Next, we move over to the input and output functions that are available in C. Now, we have been seeing about expressions, operators and the data types. Now, all these we have seen the symbols and the rules that are applicable when we use these statements in the C program. But how are we going to show the output or how are we going to show the input? So, that is what is important. So, before we begin to see the input and output functions that are available in C, let us go in for a short break. Welcome back after the break. Just before we move into the input and output functions in C, let us just have a recap of all that we have seen so far. We have seen the basic elements in C, we have seen the data types in C, the rules governing them, and we have seen the operators and expressions that are available in C, the different classifications of operators, the symbols for those operators, the number of operands on which those operators can perform their operation, and we have seen certain examples of how they are used in programming and how the results are obtained. Now, these operators and expressions exist as such in C. Now we have to give them as input to the program and obtain the desired result. So that is done using the input and output functions that are available in C. Now what is this input function? Why is it required? Reading the data from the input devices. For example, we have the keyboard and the mouse. Using that only we give the input to the system. So for that reason we need input operations. Output is for displaying the final result on the screen. It is not enough if we just remember the symbols and rules and we write the program and then nothing happens out of it. The ultimate result is we need to see the output. So for that reason the output function is very important. So a combination of those two is what are called IO functions, which stand for input and output functions. Now the classification of the input and output functions, you have the formatted functions and the unformatted functions. Under formatted functions you have the scanf, which is for input, and the printf, which is for output, and under the unformatted functions you have a list of gets and a list of puts, each of which we will be seeing in the future slides. So the unformatted functions, if you see, it mostly revolves around characters. The formatted functions can be used for all types of data. So first we will see in detail about the formatted functions. As I said, they can read and write all types of data values. A conversion symbol is needed to identify the data type. As I said, we have a format specifier, isn't it, in integers. Similarly, we have this conversion symbol when we come to the IO functions. This formatted functions, they return values after execution. Based on the return value, we have to identify whether it has returned all the values that we expect or whether some values are missing, because the return value will always be equal to the number of data values that have been either input or output. So if the return value is not equal to the data values, something is missing somewhere. So with that the compiler identifies that there is some problem. So the formatted functions, as we have seen, are the scanf and the printf statement. So first we will see in detail about the printf statement. It prints all types of data values to console. Console is nothing but the output screen. So all types of data values indicate integer, float, double and character. This requires a conversion symbol and the variable names. That is, variable name is nothing but the data value, and based on what type of data value we need to have a conversion symbol, which is nothing but a format specifier. The number of conversion symbols should be equal to the number of data values. So if we want to output 2 data values, we should have 2 conversion symbols. We cannot have 3 conversion symbols and print only 2, or have only 2 conversion symbols and print only 3. So this is an example of how this is used in the program. As I said, every C program begins with a main and an opening brace, and here we have the declaration of the symbols. Integer x is equal to 2. That means x is an integer variable holding the value 2. Y is a float variable holding the value 2.2, because it is a fraction, we use the word float. And we have the character variable z, which holds the character c. Now how are these values printed? If you see the printf statement, %d is the conversion symbol or the format specifier for the first variable x, %f for the second variable y, and %c for the third variable z. If you will remember, these 3 are the format specifiers that we studied in the integer data types. So the number of conversion symbols, we have %d, %f and %c, 3, and the number of variables to be printed x, y, z, that is also 3. So this is the syntax or the rule that is to be followed while using printf statements. So these are the details of the printf statements that are to be remembered when we write a program. And finally, you have to close every program with the closing brace. The number of opening braces and closing braces must be balanced. We have one opening brace, means we need to have a closing brace as well. So next we have the scanf statement, which reads all types of data values. This is an input statement. So in printf we are printing it to the output screen. In the scanf statement we are accepting the input from the user. It is for runtime assignment of variables. Runtime assignment in the sense, we have 2 options to give value to a variable. Like in the previous example, we can give x is equal to 2 in the statement itself, or we can simply give x, and when we are running the program or compiling the program, we can give the value at that particular time. So that is only called runtime assignment. This also requires a conversion symbol, and it requires the address operator. This we had seen in the arithmetic operators. This address operator, whatever value is being input by the user, it will be stored at that particular memory location. So, this is used to access the memory location of that particular variable. So, it indicates the memory location of the variable. This also returns the values equal to the number of values being read or input. So, the syntactical example of the scanf statement is again %d f and c ampersand a, b and c. So, this indicates that for a we should give an integer value because it is %d, for b we should give a fractional value because it is %f, and for c we need to give a character value because it is %c. So, the number of conversion symbols is equal to the number of variables, and the address operator is very important when we scan the value of variables, otherwise the compiler will return an error. So, these are the details about the scanf statement. Next we move over to the unformatted functions. So, what are the rules revolving around unformatted functions? They work only with character data type. Unlike the formatted ones, they do not require conversion symbols. They also return a value, but they return whether it is done or not done. It does not return values according to the number of variables. Either the operation is done or it is not done. It just returns one value. It is always the same. And if values of other data types like integers are passed to a function, they are treated as character data. How is this possible? This is possible because every character is represented using an ASCII integer value. So, if you give say the value 65, it will accept it as capital A. So, that is how unformatted functions work. So, in this unformatted functions you have two types of input output. One is character output and string output. We all know what is a character output, only a single character it can hold. A string output can hold a sequence of characters. So, in this character IO you have getChar, which reads one character at a time. This is for getting the input. It reads just one character at a time. Next you have the putChar function. Put itself means putting it on the screen. This prints one character on the screen at a time. Next you have this getCh and getChe. Both of them do the same job of accepting characters, but these can accept both digits as well as numbers. That is why they accept alphanumeric characters. The difference between these two is that they read alphanumeric characters from the standard input device. getChe reads as well as displays the alphabet, whereas getCh it only reads the data, it will not display the data. So, that is the difference between these two. And again you have putCh, which prints any alphanumeric character taken by the input. Now, all these do the same work of reading characters and displaying characters, but the difference is that in getCh you have to insert only characters, whereas in getCh and getChe it accepts both alphanumeric characters, digits as well as numbers. And putChar also prints only a character, whereas putCh prints alphanumeric characters, which is taken by the input device. So, this is an example for this alphanumeric character. You have the starting, you have the brace, and you have the declaration character ch. And now you are printing a line on the screen, enter any two alphabets, and you are using this getChe to accept one alphanumeric character. So, this will be accepted as well as displayed on the screen. The next statement you are using the getCh and you are assigning it to the character ch. So, this accepts a character, it will not display it on the screen, but it will assign it to the variable ch. Next you are printing the line the letter is, and you are putting this character which you just now accepted on the screen. So, then you are closing the program, and this is how you get the output. First you have that printed line, enter any two alphabets, and the first alphabet you are entering, that is say you enter A, it is visible on the screen, but the input through getCh is not visible on the screen. That is because when you get a character through getCh it will not be visible, but later when you are using the putCh function the letter is B is printed. So, when you want to print a specific letter or a specific line, you have to use either the printf statement or the putCh unformatted function. So, this is how character programs work in the C language. Next we move over to string IO. So, from the word itself we know that this involves strings. In this you have simple getS and putS functions. GetS stands for get string and putS stands for put string. So, the getS function, it accepts string through standard input, that is the keyboard. Till you press the enter key, it will keep accepting the characters, and putS does the same job of printing it on the screen. Now, here you have an example. You have the main function, you have the opening brace, and here you are declaring character CH. Here if you see, the declaration is different, it is CH and within square brackets 30, that means it can hold up to 30 characters, which forms a line. Whereas in the previous cases we had only a single character. Because it is a string, we have to have more than one character, we need to have letters. And here you are having enter string, that comes as the output. You have the getS of CH, you are getting the string hello. Then you have putS entered string, which prints it on the output screen, and you have putS of CH, which is the same hello string which you entered. So, this is how the string IO works in C. So far we have seen the formatted and unformatted functions, and in formatted functions we saw about the printf and scanf, in the unformatted functions we saw about the character functions. Now, next we move over to the library functions available in C. The first is the clear screen, which is available in the header file conio.h. This does the job of clearing the screen. For example, if you are running one program after the other, the previous program's output will remain on the screen, that will not allow you to see the current output clearly. So, before you print any output on the screen, if you give this CLR SCR within followed by the brackets, you will be able to see the clear output on the screen. Any previous data will be erased from the screen. The next is exit statement, which terminates the program. It is available in the process.h header file. And then you have the sleep function, which pauses the execution of a program for a given number of seconds. How many ever seconds it needs to be stopped for, you should give it within the bracket, say sleep of 5 or sleep of 10, it will pause the program for 10 seconds. This is available in the header file dos.h. Now, all these need to be in small letters. If you will see, the first letter is capitalized, which is not right. So, CLR SCR should be fully in small letters, exit as well as sleep, everything should be in small letters, because C accepts only small letters when they are predefined or in the set of statements. Next we have the escape sequences, which are nothing but special characters starting with a backslash. They are used to break the normal sequence of a computer. Now, if you will see the escape sequence, it is a horizontal tab, new line and backspace. We have seen all of this in the symbols available in C. So, escape sequence is an escape from the normal sequence of the program. So, that is used when we have to make some alterations in the normal execution. So, these are also quite frequently used when we write a program. For example, if you want to see the output leaving 2 or 3 lines in between, we go in for the new line. If we want to leave spaces, say we are giving the output in the form of a table, we need to give space between the headings side by side. In that case, we use a horizontal tab. So, that is why escape sequences are used. So, the questions that could be possibly asked in these tutorial sessions are the formatted and unformatted functions. What are they? What are they used for? What are the rules governing each of those? What are escape sequences? A very important question, because that is what decides how the output is going to look like. And the different types of operators that are available in C, the different classifications, and they may ask you to differentiate between logical and relational or logical and bitwise and so on. And the commonly used library functions that we have seen the sleep function, the exit function and the clear screen. Now, I will just give you a brief overview of all that we have seen in this tutorial session. We have seen the different operators in C, starting from arithmetic, that binary and unary, increment and decrement, and we have seen the examples governing each of those operators. We have seen the input and output functions in C, formatted and unformatted, and the printf and scanf in formatted functions, and in the unformatted we have seen the different types of character and string input and output. Then we moved over to the library functions, which are nothing but the commonly used functions for clearing screen, for pausing the execution of a program, or to break out of a program when we don't when we want some condition that is satisfied, we want just to terminate the program as such. So, in such a case we go in for the exit. And the escape sequences are nothing but when we want to break the normal execution of a program and then resume it again. Exit will just jump out of the program, escape sequences will give us some kind of modification in the normal sequence of execution. So, with this we complete this tutorial session in operators and expressions and the IO functions in C. Thank you.